final video, or what should be our final video, starts with our graphs. Notice that these are all the squiggly functions. These are all, or the wavy functions. These are all sine and cosine graphs. And I have put the picture of the graph on here, and then we will kind of narrow down some answer choices. Here's where a lot of our tips will come in, maybe for our unit circle page. One thing that I notice about this graph is that it goes all the way up to a 2, and it goes all the way down to a -2. And if I cut the graph right in half, it looks like, that's right at 0, that's my height of each one of the hills and the valleys. That's going to tell me the amplitude. So I know the amplitude needs to be a 2. That number in front, whatever it is, it has to be a 2. It has to be a 2. So if we look at just our answer choices, that automatically narrows me down to A or B. That's the only, C doesn't have a 2 in front, and D does not have a 2 in front. So we've already narrowed that down. That's awesome if we can do that. Now it looks like the only difference between the two is it a sine or is it a cosine graph? Those are the difference we have to decide. And there is one place that we can look, and it is right here. That only one of the graphs cross through the origin. If you don't know what it is, put it in your calculator. Go to y equals and put y equals sine of x. See if that goes through the origin. Then delete it. And then put in y equals cosine of x. See if that goes through the origin. Then delete it. The one that will go through the origin is sine. Sine always, or not always. Sine in this case will go through the origin. The only time it wouldn't is if we moved it up, down, or like left, right. We're not going to. Notice there's no left, right, up, down movements on any of these. I'm only changing the amplitude or the period. Because this one did go through the origin, I know that it's sine. So it has to be this other one. You know, I didn't figure out why this number is there, but I didn't need to. I needed to know that this number in front, my amplitude is an A, and because I know it's sine, because it went through the origin. So I know A is my pick. So let's see some other ones. 36, a little bit different. I know it's either going to be a sine or a cosine graph. Let's put our choices up here. It's either A, it's B, it's C, or it's D. See if we can narrow some out. Sine or a cosine. I haven't moved anything left, right, or up, down, and it does not go through the origin. There's nothing there. So I know one thing. This has to be a cosine graph, just based off that. If I haven't moved anything left, right, or up, down, it has to go through the origin to be sine, and this one doesn't. So this one has to be a cosine graph, which means I can eliminate, let's see, I could take out B. B is a sine graph. And I could take out D. D is a sine graph. So let's look to see what we have. It goes up to a 1, it goes down to a -1. That doesn't change. This one, it looks like the thing that is different is that B value. So I'm looking at, this is either y equals cosine of, I'm going to do it like this, 1/4 x, or y equals cosine of 4x. And we can find this. And here's how we're going to tell. I need to figure out how long it takes to go through a complete cycle. And one way we could do that was going hill to hill, you know, mountain to mountain, or valley to valley, or one up and one down. That is also a cycle, but hilltop to hilltop in this case is the easiest. And it looks like that took pi over 2. So I know something. I know that my period is pi over 2. So that's what my period is. The period is pi over 2. But what I need to figure out is, what is this B value? What would make it shrink? Because this graph has shrunk down. It got squished. It got squished together. And I need to figure out, there is some number that's going to make it squish down. And if I figure, okay, how do I get 1/2 of a pi? What number would I have to put there? That B value has to be a 4. That number has to be a 4 to make it squish down. If I want my graph to get smaller and smaller together, I got to put a bigger number inside. So this one is what, C? I got to put a bigger number inside. If I put the 1/4 on the inside, that's going to actually go the opposite direction. It's going to make this graph stretch out, and we don't want that to happen. We want it to get smaller and smaller. So I got to put a bigger number in there. So C is my final answer. How else you could do it if you got it narrowed down to these two? Plug it into your calc and see which one looks like it. See which one looks closer to the one that's on your page. All right, in our final graph, 37, we know our answer choices are A, B, C, and D. So let's see if we can eliminate some. No, none of the answer choices look like they've been moved up, down, or left, right, and this does go through the origin, so I know it's a sine graph. It's got to be a sine graph. So that means I'm down to C and D. Can't be either of these two. A and B are both cosine graphs. It looks like my amplitude is 1, but both of those are 1, so that doesn't eliminate anything for me. But the thing that's different between these two is that the period is no longer 2 pi. So I could go hill to hill, this valley to valley. This one's actually easier to go 1 up and 1 down. That is a complete cycle, and it took pi. It normally takes 2 pi. So there is some number, some b value, that is making the period go from 2 pi to pi. I've shrunk it down. I've squished my graph together. Not as much as the other one, but I've squished it together. So that means I need to put a bigger number in there. This b value, how do I get 2 pi over b equal to pi? That b would have to be a 2. That b would have to be a 2. So I would need to pick y equals sine of 2x. So that's D. I got my last answer, which is D. Again, if we were debating back and forth between which sine or which cosine graph to pick, try plugging it into your calculator to see which one looks the same. Which one looks the same. It may be harder to tell, but that is our last option. If I know my graph has been squished together, like we see it here, I know I have to pick a number that's bigger than a fraction put inside. I know I have to pick it, so I get option D. Alright, we finally made it to these other ones with triangles. From 38 on out is Chapter 6, our very last test, the most recent test we took. We're going to look at these triangles. So we're going to, 38 and 39, we're finding the measure of the indicated side, the one that has an X next to it. These two are right triangles, so we are going to use SOHCAHTOA if we can, which we should be able to. They're right triangles. It's going to work. So let's see here. I'm trying to find side X on 38. That is definitely the hypotenuse. I am given, if everything's based off that 21, I'm given the opposite side. So opposite and hypotenuse, I'm going to be using sine of 21 is 11 over X. I don't know what that is. Alright, well, even though the X is the piece on bottom, I still need to get rid of this fraction, so I'm going to multiply by X, both sides. So I get X sine of 21 equals 11. And I need to get the X by itself, so I'm going to divide by sine of 21. So this is gone. So if I input this on my calculator, we are going to definitely be sure we are in degree mode, because we are given degrees. If I get 11 divided by sine of 21, then that side, X, is going to be 30.7. It says round to the nearest tenth, so 1 decimal place is fine. If it's multiple choice, you'll know what to round to. Take your answer and see what to go to. Same thing for 39. Let's see. If everything's based off the 59, I do have the hypotenuse, but I have the side right next to it. That's the adjacent side. I don't have the opposite side. So hypotenuse and adjacent, that's going to be cosine. So cosine of 59 is X over 12. X over 12. This one's perfect because if I just multiply by the 12, I'm going to get the X by itself. X is 12 cosine of 59 degrees. Again, I'm in degree mode, so X should be 6.2. We got our 2 answers that we needed to find the side. 40 and 41 is very similar, but since you are finding the angle, you will be taking inverse of whatever. And they are still right triangles, so I can still do SOHCAHTOA. It still applies. So let's see here. I forgot to put the right triangle on 41. There we go. So let's see here. Based off theta, I have the side straight across. I got the opposite side, and I have the side right next to it. I got the adjacent side. So I'm going to try to find tangent. Tangent of this angle, whatever it is 5.3 over 14. Well, to get just to get just theta, I got to take an inverse. So I'm going to do inverse tangent of 5.3 over 14. So it looks like my angle, theta, is going to be 20.7 degrees. Angles mean inverse. Okay, I want you to pause the video, see if you can work out 41, and then check back here to see if we get the same thing. All right, hopefully you paused the video. If not, you kind of saw what I did. We have the adjacent and the hypotenuse, so I'm going to have to do an inverse cosine of 4 over 15, and I get 74.5 degrees. So if you have a right triangle, always use SOHCAHTOA. If you're finding an angle, always find an inverse. If it's not a right triangle, then you're going to have to use law of sines or law of cosines. And it says here, use the law of sines to solve the triangle. We got to find a missing piece. It looks like on this first one, I need to find AC. AC also is baby B. That's this side over here. So I know one fraction in law of cosines I'm going to work. There's the bell again. I'm going to have B over sine of 27. That piece is straight across from each other. But to get the other fraction, I need a side over sine of the angle straight across from it. I cannot do this. Don't write this down. 47, there's the bell again, times sine of 36. They aren't right across from each other. They're next to each other. So I can't do this. I can use the 47, but I need to use the angle that is straight across from it, which we would have to find. You guys are awesome at doing that. 180 minus 27 minus 36. It looks like that angle should be about 117. That's how I'm going to have to set up this problem. I need to use two fractions that I have pieces straight across from each other. That's what I have to do. Oh, and there's my phone. Sorry. So once we know these, we're just going to cross multiply and divide. So it looks like I'm going to get B sine of 117 equals 47 times sine of 27. And I'm going to divide by this piece, sine of 117. So that means this goes away, and I'm going to get B by itself. Looks like we'll probably need to round to, 1 or 2 decimal places. It doesn't really matter. So if I do 47 sine of 27, make sure on your calculator you close off that parentheses, divided by sine of 111. I'm going to get x equals 23.95. Looks like inches. You could do 24 inches. If you round it to 1 decimal place, it would get bumped up. That's what we're going to have to do to find side. I'm going to use the law of sines again, except this time I'm trying to find an angle. So on 43, I need to take an inverse. I'm looking for an angle. So I need to find angle B. One good thing, I do have a piece and the side straight across from it. So I'm going to have 15 sine of 30. I have that. I'm trying to find angle B, and I do have the side straight across from it. So it's 30 over sine of B. So just like before, we're going to cross multiply. It looks like I get 15 sine of B equals 30 sine of 30. I'm going to divide by 15. And so now I get sine of B is 30 sine of 30 over 15. That's what I get. Not B, but sine of B. So in order to get just B, I need to take an inverse sine of this whole chunk right here. 30 sine of 30 over 15. Got to enter that in. Make sure, again, after the 30, you put that in parentheses. When we type this in, out pops, well, looky there. This was actually a right triangle. So a law of sines you can use on right triangles, but it doesn't always, I don't always know this is a right triangle. It could just look like it. The picture kind of looks like it, but we can't always be sure from just throwing out a 90, but a law of sines can help us find that one. All right, law of cosines, we're going to have to be careful. We got our formulas on our unit circle page anyways. Let's do 45 first. I think the angle ones we're more comfortable with. We're trying to find angle A. We're trying to find this one. So that means we're going to have to use that cosine of A as some scary formula. I want you to write this, though. Next to the 6, I want you to write last. That is the piece that on the numerator I need to write last. That's the subtraction piece. Because no matter which one of those formulas you pick, whether you're finding A, B, or C, it's always the other two sides squared. I add those together. And then the side straight across from it is the last one you write, and you subtract that off. So I get 14 squared plus 9 squared minus the 6 squared. And then those first two numbers come back again. Over 2 times 14 times 9. I'm going to try to avoid calculator errors. I don't want to get an error or miss a parenthesis, so I'm going to simplify the top and then simplify the bottom. It looks like the top I get 241 over 252. And then that is what I'm going to take an inverse cosine of. I have to inverse it because I'm finding an angle. Can do that. And it looks like A is Well, if we round it to 1 decimal place, it's about 17 degrees. You could put 16.99, but that's going to round up to 17 degrees to find that. Again, I took an inverse because I was finding an angle. Don't let the formulas freak you out. Don't let them freak you out. You got A's, B's, and C's, put them in their spots. For 44, it says find side BC. Side BC has another name, so that is also baby A. So we're going to find baby A. We need the formula that starts with the little a squared. And the little a squared says, I take the other two sides and I square them. I subtract off 2 times one side times the next side times cosine of that angle straight across from it, 34. So I can find that. I'm going to type it in my calculator as one gigantic square root, so I can get A just by itself. And A, if you get on your calculator, it's like 9.995. Basically, it's 10 centimeters. That's the length of it. 44 is easy to plug in on your calculator. It doesn't give you as many spots for error. I mean, if you really want to be careful, maybe put parentheses around this whole big chunk back here when you subtract it off. But 45, I'd be very careful about that fraction. There's no harm in simplifying top and then bottom. 46 and 47 are our area formulas, and we have two different ones. If we have 47 as side, 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 that means I'm going to use Heron's formula. That's that crazy one with the square root. 46 is side, angle, side. That means I'm going to use the one that starts with the 1/2. So if we start with the side, angle, side one, 46, I think this one's a lot easier. My formula says, the fancy thing, it says 1/2 AB sine of C. Basically, it just means two sides and the angle in between it. So I have 1/2 times 9 times 13 times sine of 21. And if I just type that straight into my calculator like I see it to the nearest tenth, if I round it up, I'm going to get 21 square kilometers. That is the area of that triangle. 47 is a little bit different. Because of Heron's formula, we know Heron's formula is the big square root, and it says S times, oops, I messed that up. Let's start over. S times S minus A times S minus B times S minus C. All those other sides. But we got to find S first. That's adding all the sides up and dividing by 2. So if we do that, we're going to get 11 plus 9 plus 14 all over 2. We should, excuse me, get 17. Once we have that piece, once we have S, I kind of did this out of order. There we go. Once we have S, then I can just type it straight into my calculator. It looks like I get 17 times 17 minus 9 times 17 minus 11 times 17 minus 14. I type it in, out pops 49.5 square kilometers. They're both kilometers in this case. It could be square inches, square centimeters, whatever unit they gave you. So know the difference between those two formulas. Maybe you write next to Heron, side, side, side. Maybe you write next to the 1/2 one, side, angle, side, whichever one. Whichever you want, just make sure you kind of know the difference on your unit circle. Alright, we've finally made it to the last three, 48, 49, and 50. And you get to see my beautiful sketches. So here we go. Submarine is cruising at the depth of 85 meters. So let's get that. Here's the water. There is a sub down here. It's beautiful. And it's got the little thing that comes out of the top of it. So we got a sub. Just pretend it's a sub. It's got a little scope that comes out of the top of it. It's cruising at a depth of 85 meters. So it's 85 meters below. It's on a trajectory that's going to pass directly below a ship. So that means the sub's going this way. There's some boat up here that is going to pass right underneath. If theta is the angle of depression from the ship to the sub, and remember, angle of depression has to be attached to ground level. In this case, that's the water. Find the distance from the ship to the sub when theta is 35 degrees. Okay, so I got 35 degrees. And I can kind of see where this triangle is going to be made out. One thing I know, it's a right triangle. I'm going to go straight down to find the depth. We just need to figure out which other side of this triangle we're trying to find. It says find the distance from the ship to the sub. That would be the hypotenuse. From the ship down to the sub. This other side over here, that's from the ship to right over the sub. I don't want that. I want from the ship to the sub. So it looks like, based off the 35, I'm trying to find the hypotenuse, but I know the opposite, so I'm going to have to use sine. We got that. Sine of 35 equals 85 over x. I know, even though the x is on bottom, that's what I got to multiply both sides by. We can do that to get rid of the fraction. So we're going to divide by the sine of 35. It says to the nearest meter, so we want the nearest whole number. That would be b, x equals 148 meters. That is how far in a straight line from the sub up to the ship it's going to be. A triangular parcel of land has sides 900, 820, and 350 feet. Find the area. So I have side, side, side. This is going to be Heron's formula again. You can draw a triangle if you want. 900, 820, 350, whatever. It doesn't have to be to scale. But basically we just need to figure out, okay, I need to figure out S. S looks like if I do 900 plus 350 plus 820 and divide that by 2, then I get 1035. So I need to plug that into my calculator. It's going to be a crazy square root, but we can do it. 1035 times 1035 minus 900. 1035 minus 820. 1035 times 3 minus 350, the last piece. And this one says to the nearest foot. So if I get 143,450.3, that's going to round down to 143,450 square. I can't write today. 150 square feet is where it's going to round down to. So just pay attention about what it tells you to round to, but since they gave me every single side, I know that had to be Heron's formula. All right, last one, in our favorite problem in the world, there's a ladder leaning against a building. So let's see, we need a building. It's going to have windows. It's going to have a door. There's a ladder that's leaning against it. It is 15 feet long. Someone is deciding to practice whistling outside my door today. Good times, people. It says the ladder makes an angle of 70 degrees with the ground. So not this angle up here. That is not the ground. Don't do that angle. This angle here is 70 degrees. How high is the ladder? How high above the ground is the top of the ladder? So that means how high above the ground is the top of that ladder? We're trying to find that side of my triangle. It's another right triangle, so I can do SOHCAHTOA. It looks like I'm given the hypotenuse, but I'm looking for the opposite. I'm looking straight across. So I'm going to try sine of 70 degrees is x over 15. All I need to do is multiply both sides by 15. And this one, it looks like all the answer choices are whole numbers. So I get x equals 14.09, which means that's going to round down to 14 feet above the ground. So that is option A. So as we've been working through all of these, if there's any tips that you think maybe I'm going to forget that, or maybe it would be nice to have that down, write it on your unit circle page. If there's any problems you have a question about even after watching the video, ask me. Come during tutorial, come during lunch, ask during class, come after school, ask on Edmodo. You have options. But remember that there's a lot of different things. It does seemingly go in order that we taught it in class, so we can kind of find all the triangle problems together. But really use your time in class working on all these problems and filling out your unit circle page to help you get the best grade possible on your review. You guys will be awesome.